Hi there. In this video, we're going to talk about inverses of functions. So given a function, one can try to find the inverse of that function. What does that all mean? Well, you know, a function transforms numbers into new numbers, right? X's into Y's. Well, the inverse function is going to take the Y's and turn them back into the X's. So that if I take a number, plug it into the first function, and then evaluate, I get that new number, I plug that into the inverse function, I get back to the original number. So the inverse functions are opposites of one another. So let's take an example. Suppose we have the function x over 2 minus 3. Okay, that's our function. So this function sends 2 to negative 2. It sends 4 to negative 1. It sends 8 to 1. And it sends 12 to 3. Now what we're looking for is a function that does the opposite. That is, it'll send negative 2 back to 2. It'll send negative 1 back to 4. It'll send 1 back to 8. And it'll send 3 back to 12. Now we need it to work not just for these numbers. That was just an example. But we need it to be such that no matter what number x I started with, wherever it goes, the inverse function will send it right back. Okay, so let's find the inverse of our function. Now, what is this function doing? As we saw before, it takes a number x and it's spitting out a new number y. Now, what is y? How do we compute y from x? Well, it's given by this expression right here. Y is equal to x over 2 minus 3. Now what we're looking, this is the function f. What we're looking for is the function that goes in the opposite direction, which we denote by f to the negative 1. Now I want to point out this is not an exponent. This is special notation for inverse functions. It is usually different than using an exponent of negative 1, so do not confuse those things. It's unfortunate that we have to use the same notation for two different things, but we run out of symbols in math, so we have to start doubling up. This denotes the inverse function. Okay, so what I want to do is I want to find a way to compute x from y. Well, we have this relationship. Let me write it down here. If I want to compute x from y, what I really need to do is solve this for x. So I'll solve this for x. So the first thing I'll do is I'll add 3 to both sides. All right, let's go over here. Now I'm going to multiply both sides by 2. Right? So on the left-hand side I have 2y plus 6, and on the right-hand side I have x. Well, I've done it. I've solved for x. Let me write it with x on the left-hand side. So this is the inverse function applied to y. The inverse function applied to y is 2y plus 6. These are the instructions that I would need to convert this number, whatever it was, back to the original x. Now I want to point out one more thing. Usually we write the function as a function of x. Now that seems weird because x lives over here and the domain of f inverse is over here. But that doesn't matter. We can call variables whatever we want. So if we're going to call this x, I'm going to, as a final step, I'm going to replace all the y's with x's. So if f inverse of y is this, then f inverse of x would be this. So that is the routine. We find our expression, we set it equal to y, we solve for x, and then we replace all the y's with x's. And that is how we find our inverse function. Now, something that you should check on your own is verify that we got just what we were describing. This is a function that will take negative 2 back to 2, negative 1 to 4, 1 to 8, 3 to 12. It does the opposite of what our original function did.